Okay, so Marty sells tacos and burritos. Oh boy, talk about needing to be up at 5:40 in the morning. So, from a food truck. Oh, who would bring a taco or a burrito from a food truck? At a farmer's market. It's like going. She sells burritos for $3.50 each and tacos for $2 each. She hopes to earn at least $120 at the farmer's market this Saturday. Identify three combinations of tacos and burritos that are more. Okay, 1,000 of each would be more. You agree?
Yeah.
In fact, 100 of each would be more, right?
Yeah.
I could even say 50 of each. The point being, there's lots and lots of combinations. Oh, now this gets a little more challenging. I'll earn exactly $120. Did anybody come up with any? Go ahead.
Do they have to be the same amount or different
No,
amount?
they can be different amounts.
Oh, okay.
So, did anybody find any combinations that come up to exactly 120? All right, well, 0 burritos and 60 tacos. What? That's one, but we need 3. Go ahead.
I think it was 16 burritos and 32 tacos.
16 burritos would be 48 and 856. And how many? And 56. Oh, 56 from that would be 33.
Yeah.
Is that what you said?
32.
32? Yes, 32 is good. Yeah, I think we're good. Okay. And anybody else have another combination? All right, well, let me go for 20 burritos. That's $70. That leaves 50, which would be 25 tacos. Okay? So we got combinations that'll be exactly 120. And then identify them that will not earn at least 120. I could do 1 of each, I could do 10 of each, I could do 5 of each, any combination there. That's easy too.
5 of each.
What's that?
Like that.
You can't.
Yes, you can.
You can
5
of
of
a
a
taco.
taco. Yes, you can. Hey, my name is Phoebe. Can I only have half because I'm not that hungry and I don't want to pay for the whole thing?
Oh yeah, that's gonna work.
Yes, you can.
All right, graph it.
I've done it.
Okay, ready? How much was it for each burrito? $3.50. So 3.5 times the burrito plus what? 2 times the taco
2 times the taco.
is going to equal how much?
120.
120. Now the first thing I want you to realize is that we don't need these sections.
Cool.
Okay. In fact, I'm a little disappointed in myself. I shouldn't have even shaded those because I got to shade the graph. That's a boo-boo. Okay. The b is like x, the c is like y. We all good there? So minus 3.4b, 3.5b, minus 3.5b, and I get 2 times the number of, I use the c. C is for taco. Okay. Who knows why? And divide by 2. C is negative 1.75 burrito plus 60. Now, I'm going to let each of these things be 5. This is going to be pretty ugly, but anyway. 1, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60 right here. And let's see. Oh, they wanted these to be greater than or equal to, didn't they? Yeah, they did. So greater than or equal to, rather than just equal to. And the slope is down negative 1.75 over 1. So we know these guys are 5s. Now, I assume these guys have to go, oh boy, this is going to get ugly in a hurry. This is going to have to go by 5s also.
Oh no, what you doing to me?
Right? Tell me about it. Which means I'm going to have some very, very, very little places to move here. You know what? It's very difficult for me to move over 1 on this, right? So let's think about other ways to do this. Negative 1.75 is really negative 7 over 4. If you were having a little problem with that, you do math enter on your calculator, right? It'll tell you that. Now, the problem is that this is set to go over by 4s. So let's turn this into 20ths. And I'll show you the trick behind this. This is pretty slick. 4 times what's 20?
10.
So 7 times 5 is 35. So now I'm going to go down 35, 5, 10, 20, 25, 30, 35, over 20. And that establishes my 2 points that are perfect on the line.
No.
See how I did that?
Yeah.
All right, I created a denominator that would be red here, and now this is a solid line because it's or equal to. You gotta go right there. And then I'm gonna shade above. And there we go. Says greater than or equal to, so I'm shading above. Yes. Because this would be, if I had, this one here is tacos, and this one here is burritos. So this would be if I had no tacos and 60 burritos, or I'm sorry, the other way around, this is tacos, and this is burritos. This would be if I had 60 tacos, and this would be if I had whatever burritos.
What about the 35?
Well, this is going by fives, 5, 10, 15, 20, okay? All right, so the point was just to say this, that when you do this graph, they spoke of a few minutes ago, combinations that earn at least, those are all in that shaded area, combinations that earn exactly, those are on the line, and then they talked about combinations that were not enough, and that's there, okay? All right, so, and as I just erased it, which I shouldn't have done, but I'm actually a little bit concerned, I might have reversed axes, but if I did, it's a little too late. Okay, so the next question talks about solve the following system of equations for the variables. Is this an elimination one?
No.
No. How do you know it's not elimination? They don't line up, right?
Yeah.
Now, it's not elimination, so I'm going to write 2x minus 3 times Colton Haynes is equal to negative 6. Is that Colton calling? From what I understand, he's more likely to be calling me than Yasmin.
What?
I don't think it was just
I don't want to get Yasmin too mad at me. She might be killed.
Yasmin.
Okay. Now, distribute the negative 3. 2x minus 9x minus 3 is negative 17. Negative 7x, and I'm going to add the 3 in my head. It's negative 14. Dividing by negative 7, x is 2. I'm just trying to save some space here. I think you can follow that, right?
Oh.
Negative 14. Come on, can't you read hieroglyphics?
Oh, yeah.
One second.
Where did you get the 7 from?
One second.
2x.
Negative 3 times not 3 is 3x is negative 9x. 2x and negative 9x is negative 7x.
Oh.
We good?
Wait. Yeah, I'm good.
I see now.
Very nice. Revelation is a beautiful thing. Okay, so now I got to go back and get y. It says here that y is 3 times x plus 1. X is 2, so y will equal 3 times 2 plus 1. So y is 7. So x is 2 and y is 7. If I were to graph these two lines, what would be the coordinates of the point of intersection?
2, 7.
2, 7. Very good.
That's 2.
Right? That's what we mean by x, y. X comma y, 2 comma 7. Okay, so there's a song by Alec Jackson called Way Down Yonder by the Chattahoochee. Learn about living and a lot about love. Right, it's something like that. He talks about where you throw a ball at a pyramid of cans. So this is a very southern, down by the Chattahoochee kind of thing. At a state fair, there's a game where you throw a ball at a pyramid of cans. If you knock over all the cans, you win a prize. The cost is $3 for one, but if you have an armband, you get 6 throws for $1. The armband costs $10. Write 2 equations, or 2 cost equations for the game in terms of the number of throws purchased. One with an armband, one without. Go ahead, just write the 2 equations.
Okay. My pen failed.
Let's not worry about the best deal. We're not going on Groupon right now.
Groupon.com.
Okay, so, $3 for a throw, but if you have an armband, you get 6 throws for $1. Okay. Let's see here. 2 cost equations. So the cost is, let's see, 3 throws for $1. And if you have an armband, you get 6 throws for $1. So one would be,
I see that. You got
I'm going to let A stand for armband and T stand for throw, right? So 3 times the number of throws is equal to $1. That's a true statement. Okay, it seems kind of weird, but we'll go for it. Here, next it says, the next one says that you're going to get 6 throws for $1, but you had to pay $10 for the armband. So this is very, very awkward. 6 throws for $1. Let me think this through for a minute. What's that? All right, so here's the bottom line. This one, you're going to have to pay an additional $10. All right, so the total cost is going to be, well, it's not that simple. You get 6 throws for $1. The total cost is going to be, how do I represent? Oh, throws. Do I do throws in terms of cost?
Yeah.
But if I do throws in terms of cost, the throws is going to equal, it's not 6.
No, 11.
It's what? Huh?
Wouldn't it be 60 equals 11?
No, because we want to be able to do this for multiple levels of throws. Like if you did, for example, let's go with the $1 one. $1, $2, $3, $4, and so on and so forth. So, what's that?
Maybe because you get.
Yes, I'm going to go back and change the first equation for sure. But as I'm thinking about this, the cost is equal to, what is it? It says, right, 2 cost equations in terms of the number of throws purchased. Okay, one without an armband and one with. All right, so the one with the armband is going to be the number of throws purchased. Then I have to divide by 6 plus 10. The number of the cost is the number of throws purchased divided by 6 plus 10. In this case, the cost is the number of throws purchased divided by 3.
Now, can you explain the equation?
Well, if I want to find the cost here, I just take the number of throws purchased and divide by 3. For example, if I bought 21 throws, what's 21 divided by 3? 7, it'll cost you $7, right? Over here, if I bought 24 throws, it would be $4 for 24 throws, but you had to pay 10 for the armband. Go ahead.
Does that say 6 equals or C?
C equals.
Oh, I thought
C
that was
equals. Sorry.
C.
Okay. So then it says to graph the 2 equations. Please remember those 2 equations so that I can put them on here. Ready? We said that the cost was the number of throws divided by 3, and the other one, the cost was the number of throws divided by 6 plus 10.
No, I didn't remember it. You
Okay,
remember
I didn't want to forget it there. So now we can go through, ready? 0. And I'm going to go by 2 so I can fit more in. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 2, 4, 6, 8, 30. 2, 4, 6, 8, 40. And then over here, I'm going to go by, I'm going to go by 1s in case the answer works out to be strange. Like a 7 or an 8. 10, 11, 15, wait, no, that's 14, 20. All right, I don't know if the scale's going to work. Eventually it's going to work. I just don't know if it's going to fit on this. So this would be a slope of 1/3 and a y-intercept of 0. So here's at 0, but we got to be careful about the 1/3. I'm going to go up 1 over 3, and because this is in terms of 2s, 4s, and 6s, let's say that this is equal to up 2 over 6. Do we all agree? So I'm going to go up 2 over 6. Up 2 over 6. Up 2 over, let's see, from 12 it would be to 18. Wait, that makes 6. Oh, look what I did. I'm such an idiot. 8, 10, 12, 14. I need to erase.
No, you're going up by.
Yeah, no, I completely botched. I went from 2s to 1s here. Sorry about that. Ready? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
I thought we were going by twos.
So, no, we're gonna go by ones. So now, up 2 over 6, up 2 over 6, up 2 over 6, and here is my line. And this would be the line C equals T over 3. Now, it's the same thing as the slope of 1/3. The problem is that that ends up in the middle of the box. So by doing 2 and 6, I get to the part of the box that's not there. Now, this one has a y-intercept of 10. But now it's up 1 over 6. And up 1 over 6 puts me in the middle. The next one's up 1 over 6. Up 1 over 6. Okay, so here's this line going. Now, is it pretty obvious that they're eventually going to cross? But they don't cross on the graph. So the last question says, does it make sense to buy the armband? What do you think?
Not really.
Why?
Depends on how much you plan on playing.
That's right. If you're going to play a little bit, does it make sense? No, a little bit's down here. And clearly it costs less for the red equation, C equals T over 3. But if you're going to throw a lot of throws, then it makes sense. Yes,
What if the armband gets you different games that you want to play?
it doesn't say that. It says we're all throwing over the pyramid cans. There's a guy, Tim McGraw, who's a singer, who says that he met a girl at a fair, and he says, I throwed out my arm, but I won her that teddy bear. So I like how he says I throwed out my arm. Throwed out my arm. Okay? Okay. All right, so listen, all we wanted to do today was reinforce the idea that you can do it graphically, you can do it in inequalities, we can do it algebraically, we did some there. You should have all techniques at your disposal for Monday and Tuesday.
So what does that nice relearn package do?
The nice relearn package due Monday. Oh, yeah. I have to see it with my hands on Monday, then I can get back to it, but I want to see it in my hands so I know we're good to go. Extra help Monday morning also.
I wrote way down for earth science, guys. Don't worry.
Oh!